Class, this is the first video on section 6.4 in your textbook, the inverse trigonometric functions. So you have learned all about the 6 trigonometric functions. Now in this section we're going to learn about their inverse trigonometric functions. So before we do that, I want to do a little review of what an inverse function is. An inverse function is a function that reverses or undoes the action of another function. And so we will demonstrate that concept here with 2 algebraic functions. We have f of x is equal to 3x plus 1, and we have g of x is equal to x minus 1 over 3. And we're going to show that f of x and g of x are inverse functions of each other. The input and output to f and g are reversed. That's what we mean by an inverse function is a function that reverses another function. So if we evaluate f of x at x equals 2, we have f of 2 is equal to 7. But then if we evaluate g of x at x equals 7, we have g of 7 is equal to 2. So the input 2 to the function f is the output to the function g, and 7, the output to the function f, is the input to the function g. So the input and the output of each function, right, is reversed of the other. So in the second example, right, using these 2 functions, we have f of minus 1 is equal to negative 2, and then g of minus 2 is equal to negative 1. So minus 1 is the input to f, and it's the output to g. Minus 2 is the output to f, and it's the input to g. That's how inverse functions work. Okay? Input to one is output to the other. Output of one is input to the other. Lastly, third example, we have f of 5 is equal to 16, and g of 16 is equal to 5. So you can see 16, the input to g, is the output to f, and the output 5 of g is the input to f. So f of x and g of x are inverse functions of each other. Okay? They reverse each other. Now, if 2 algebraic functions, f of x and g of x, are inverse functions of each other, then it's true that if you take the composite of f and g, f of g of x, you just get x. And if you take the composite g of f of x, you just get x. That happens when you take the composite of 2 algebraic functions that are inverses of each other. Now, but not all functions have an inverse function. Only one-to-one functions have an inverse function. And so we'll demonstrate that down here with this example. You know the definition of a function: for each input there is exactly one output, right? So a relation is a function if each input has exactly one output. And so we can see here this relation defines a function because the input A is mapped to the one output, the number 3. The input B is mapped to the output number 1, and the input C is mapped to the output number 2. So each input has exactly one output. So this relation defines a function, and we call that function f. Now, this function is a one-to-one function if we can switch the role of the output and the input, right? The output numbers 1, 2, 3 are now the input numbers down here, 1, 2, 3, and the input letters A, B, C up here are now the output letters down here. And then we switch the direction of each of the arrows. So instead of the arrow going from A to 3, it now goes from 3 to A. So looking down here, you can see that the input 3 has the letter A as its output. The input number 2 has C as its output. And the input number 1 has B as its output. Right? The arrows are just reversed up here. And so you can see now we have, this is a function, right? Each input has exactly one output. So the function f up here is a one-to-one function. We switch the input set and output set, and we have another function. The notation for the inverse function of f is this right here. It's f with a -1 in the superscript. This is not, the -1 in the superscript does not mean inverse function. It's just fancy mathematical notation to represent an inverse function.